That's just how I feel. Trying to reach the things that I can't see. For having a vision, my prediction. Am I wrong? Thinking out the box from where I stay. Am I wrong? Saying that I choose another way. I ain't trying to do what everybody else doing, just cause everybody doing what they all do. If one thing I know, I'm forward, I grow. I'm walking down this road of mine, this road that I go home. So am I wrong for thinking that we could be something for real? Now am I wrong for trying to reach the things that I can't see? That's just how I feel. That's just how I feel. That's just how I feel. Trying to reach the things that I can't see. For having a vision, my prediction, I will be on top of the world. Don't look back, always do what you decide. Don't let them control your life, that's just how I feel. Oh, fight for yours, so don't let go. Don't let them compare, you know. Don't worry, you're not alone, that's just how we feel. Am I wrong? Am I wrong? Thinking that we could be something for real. Yeah. Oh, no, am I wrong? Am I wrong? For trying to reach the things that I can't see. All right, here we go. We're going to look at 9.3 again today, and then on Tuesday we're going to review chapter 9, and then on Thursday you will take the chapter 9 test, which will serve as the final as well. You'll take the chapter 9 test / final in the Zoom session, and we've designed it so that it should be easily taken within a half an hour. So make sure you're studying up on this chapter. We are going to review on Tuesday. I'll have an assignment for you, of course, so you get an opportunity to look at everything again, and I'll try to design the review to reflect what you're going to see on the test. So let's get into our second day of 9.3. We'll do a few problems, and then we'll get out of here. You do have a quiz tomorrow, and I will post that at 8 a.m. Tomorrow. And then get it done, turned in. It's not multiple choice. It is going to be on paper. I believe, if I remember right, you have some graphs on there. So do it on paper and then turn it in on Google Classroom, of course. All right, so that kind of gives you an idea of where we're going and what we're going to do next week and how we're going to finish out the year. So without further ado, let's get going on this. I have your videos on top of the calculator on my screen. All right, find the rectangular coordinates for each point with the given polar coordinates. Round to the nearest hundredth if necessary. And I've picked number 1 here, and I know you've already done this problem, but I just thought I would just grab some examples from right out of the book. Rectangular coordinates. Well, if you're going to go from polar and have an r and a theta, it's really just unit circle stuff. So we're going to go, well, I shouldn't write r. I'll write 2 cosine of pi over 4 and 2 sine of pi over 4. And then we know this one. We know it's square root of 2 over 2, and we know that sine of pi over 4 is also square root of 2 over 2. Now the 2's, they're going to cancel out. So that's where you get an answer. And they have I left the answers on here. Square root of 2, square root of 2. Now we know pi over 4 is a known angle, so we're expecting some exact answers. So for like number 6, we'll have negative 13 cosine of negative 70
and 13 sine of negative 70. And we don't know those, so we're going to go to the calculator. Now I'm using degrees, so we have to make sure our mode is in degrees. So I would have gotten some wrong answers here. Negative 13 cosine of negative 70. And while we're at it, we'll just do negative 13 sine of negative 70. And there we get the answers that we see, the negative 4.45 and the 12.22. So going from rectangular to rectangular, unit circle is really what it is, except it's not unit circle. It's, you got to multiply it times whatever the radius is. Find two pairs of polar coordinates for each point. So I got to remember to find two pairs of polar coordinates for each point with their given rectangular coordinates if we're between 0 and 2 pi. So that suggests that we're going to give our answer in radians. Round to the nearest hundredth if necessary. So I'm going to change this calculator to radians while I'm thinking of it. I picked number 13 because that's 710 is in the principal quadrant. So 710 is probably up somewhere, I don't know, right here. So that's a very, rough estimate of where 710 is. I just know it's in the first quadrant. Well, we want the R. We want R and theta. We want R and theta, but we want two of them. All right, so that's what we've got to fill in. R is equal to get the radius of this circle, we would do x squared plus y squared square root, because it's really, we're getting the hypotenuse of this triangle. So square root of 49 plus 100, that's square root of 149. So let's put square root of 149 here. And then to get the angle, we want inverse tangent of y over x, so 10 over 7. Inverse tangent of 10 divided by 7. Oops, I missed the divide. Divide by 7. 0.96, so almost 1 radian. So 0.96. So that's going this way, like that. That's going with a positive radius with a positive angle. How about a positive radius with a negative angle? So I'm going to take that value and we just have to subtract 2 pi. So we'll go all the way around in the negative. So if I minus 2 pi, that should be the exact same place. And it's between 0 and 2 pi. All right. Yeah, I can do that. I just realized that. So let's go, because that would be a wrong answer because I have a negative value. So I got to go over here, down here, make that negative, and then go in the positive direction. All right, go the positive direction. So I got to take the answer I have, that 0.96, and add pi to that. So that's how I can fix this. All right, here we go. So we're gonna go 0.96 and we're gonna add pi. That'll keep us between 0 and 2 pi. There we go. Between 0 and 6.28 is what it really is. All right, so then we have 4.10. So I need to read the instructions carefully. Luckily, I caught that. All right, number 14. Negative 13.4. Negative 13.4 is probably about right there, relatively speaking. Now I know it's in the second quadrant. And if you're in the second quadrant, that's kind of a problem with inverse tangent because it's now going to give me an answer in the fourth quadrant. But let's do the R first. R is equal to square root of, it's a Pythagorean theorem on those two values there. So 169 plus 16, square root of 185. So square root of 185, and then now to get the angle, we need inverse tangent of 4 over negative 13. Now it's going to give us an answer that's in the second quadrant. So inverse tangent of 4 divided by negative 13. And there's that negative answer. So it thinks we are down here. There's the negative 0.3-ish. So we need to add pi to that. Let's add pi to it. Add pi, and that'll be between 0 and 2 pi. So we have 2.843. So now I need another answer. Let's do this. Let's go negative. Let's go negative square root of 185. And if we add, let's see, we got the 2.84. If we add another pi to it, that'll be between 0 and 2 pi, or between 0 and, if you take 2 times 3.14, that's between 0 and 6.28, really. So if we add another pi, we get 5.98. 5.98. There we go. So there's 2 pairs of polar coordinates. So I got one in the first quadrant, one in the second. How about one in the third quadrant, and then we'll move on. So number 15, -6, -12. That's down here, but in the third quadrant. So r is equal to the square root of 36 plus 144. That's square root of 180. I think 180 is 36 times 5, right? Yeah, that's 30, 15, that's 180. So that's 6 square root of 5. So the r is 6 square root of 5. And now we need the angle. Kind of running out of room here. Inverse tangent of 12 over 6, right? Negative 12 over negative 6. So inverse tangent of 2, but now it's going to give me an answer in the first quadrant. So 1.1, but that would be up here. So 1.1 right there. Well, that's between 0 and 2 pi. So what we could do is just make that negative right away and do 1.107. There's 1 point right there. That'd be up here, but then negative would go in the opposite direction. Then we do 6 square root of 5 and take this value right here and add pi. So we're going from here and adding a half a circle, add pi radians. So plus pi. And that's 4.25 rounded to 2 decimal places. So it's the inverse tangent stuff that's a little tricky. Type questions, unmute yourself if you have any, if I'm going too fast for this. All right, the instructions: identify the graph of each rectangular equation, then write the equation in polar form, support your answer by graphing the polar form. So identify the graph. I've chosen number 26 and 27. So 26, identify the graph. Well, it's a line. More specifically, it's a vertical line. Then write the equation in polar form. Well, x is r cosine. R cosine is equal to -2. So r is equal to -2 over cosine of theta. And just like we write lines y equals, we want to write polar equations as r equals. So r is equal to -2 secant of theta. And then support your answer by graphing the polar form of the equation. Well, I don't know if you're real familiar with graphing that. Probably very familiar with graphing this. So I'm just graph it is what it comes down to. I don't care which one you use because it's going to be the same graph no matter which one you use. So x equals -2 is a vertical line over here where x is -2. 27, circle. That's what 27 is. Let's expand it out. X squared plus 10x plus 25 plus y squared is 25. We can minus 25 from both sides. Not only do that, but x squared plus y squared is r squared. That's one of the tools that we have, one of the relationships that we have. So I minus 25, we still have plus 10x. Well, 10x is r cosine of theta. And that's equal to 0 because we've subtracted 25 from both sides. So now r squared is equal to -10 r cosine of theta. So we subtract that over and then divide both sides by r, -10 cosine theta. And then now, I mean, it doesn't matter which one you use to graph, but just now it says graph this. Well, if we look at cosine, negative cosine affects the x, but in the negative direction, so off to the left, with a diameter of 10. So if I make this -2, 2, 4, 6, 8, 10. If you print out polar graph paper for your quiz or your test, or if you're using it and you're going to have to use something other than 1. Make sure you mark that. Now the center is right here because we have a diameter of 10 means we have a radius of 5. So 2, 4, 5, that's about right there. 2, 4, 5, that's over here somewhere. And then here's our circle. Now that matches with the rectangular because this would say that the center is -5, 0. Remember, you always do opposite of what's in here. And then this is actually the radius squared. So this is saying that the radius is 5, just like we have with the polar. Write each equation in rectangular form, identify its graph, support your answer by graphing the polar form of the equation. Well, just write the graph. It doesn't really matter which form you use, I would imagine. Let's grab number 37 here. 37. To get it into rectangular, I'm going to take the tangent of both sides. Tangent of theta is equal to the tangent of -pi/3. Well, the relationship that we have as one of our tools is that tangent of theta is equal to y/x. So I can turn tangent of theta to y/x. Now I'm going to get the value for this. Well, here's -pi/3. And on the unit circle, that would be 1/2 (-√3/2). And then the tangent would be (-√3/2 over 1/2. So (-√3) would be the value of tangent for that. So I can turn this into (-√3). Well, that ends up being the slope. (-√3x) when I multiply the x over. Well, now I have to graph this. Now, it's going to be kind of tough to graph a slope of (-√3), but it's really easy to graph this right here, this version. It even says graph the polar form. This says that the angle must be (-√3), and then that means since there's no information on r is anything or everything. So this would actually be all of the positive r's going in this direction. So it's that line, but it's the same line over here. This would just happen to be all of the negative r's. So it's this line right there, and that line has a slope of (-√3). And not only that, but a y-intercept of 0. So it intercepts here, down (-√3 over 1, I suppose, is how you would look at that. 39 I chose. R equals 4 cosine of theta. So on this one, we're going to multiply both sides by r. So r squared is equal to 4r cosine of theta, because I want that r cosine of theta. I want the r squared also, because r squared is x squared plus y squared. R cosine happens to be x, so 4x. And you can look at the notes that we had yesterday with all those relationships. We had x squared plus y squared is equal to r squared. X is cosine theta, y is sine theta. No, r sine theta. X is r cosine theta, y is r sine theta, and then in tangent of theta is y/x. Those are the 4 that we had yesterday. Well, we don't leave conic sections like this. We minus the 4x over. Now that's 0 plus something, so we're going to add something to both sides. Well, 4 divided by 2 is 2. 2 squared is 4, so we end up adding 4 when we complete the square. So this factors into x minus 2, x minus 2. And then we got plus y squared is equal to 4. Now we need to graph either version. Well, this is a circle. Cosine affects the x, and it's positive, so it's going to be off to the right. And I could probably cheat here a little bit, because I know that the center is going to be 2, 0. And we need to go right there. Oh, that looks pretty good. That's pretty good. Now, does that match what the rectangular has? Well, this says that the center would be 2, 0 with a radius of 2. So it's the exact same circle, of course, it has to be. Next one. So first technique, take tangent of both sides. This one is take tangent of both sides. This one's multiplying by r. This one is you turn cosecant into 1 over sine. So I tried to pick each of the different techniques that you're going to have to apply. So r on number 41 now, all right here, r is equal to 8 over sine theta. That'd be the same thing. Multiply by sine on both sides. So r sine of theta is equal to 8. Now that's what I wanted. That's one of the tools that we have. y is r sine of theta. So this becomes y equals 8. That's pretty much it. I mean, it's a horizontal line. Identify the graph. I didn't do that down here either. This is a circle. I forgot on 37. What is this? This is a circle. No, this is a line. What? Oh no, I did 37. This is a line. This is also a line, but it's y equals 8. That's up here. I only have 7 spaces. So here's 8. 1, 2, 3, 4, 5, 6, 7, 8. There we go. So there we got 41. The technique is change cosecant into 1 over sine or secant into 1 over cosine. And then 42, I thought, had its own little technique. We need to square both sides. So square. So 42, I want r squared is equal to 16. R squared is x squared plus y squared. So there it is. It's a circle. It's a circle with center 0, 0 and a radius of 4. So when you graph it, 1, 2, 3, 4. There's that circle right there. Any questions? All right. Well, that went pretty quick. Hopefully I didn't do that too fast. I'll post this video and you can go through it again if you absolutely have to. The assignment is the evens. I think 2 through 44 evens. And I put a spot on Google Classroom to turn that in. But this is unit circle. It's all about unit circle. Except instead of 1, we have a 2 or a 5 or a negative 13 there. Unit circle. Then this one is this is Pythagorean theorem for R. And then the other thing you have to do to get the theta is the inverse tangent. And that's where it gets a little tricky because inverse tangent is going to put you in that principal quadrant. You can't get second quadrant, you can't get third quadrant answers for inverse tangent. So that's where it gets a little tricky. Identify the graph. So there's a couple techniques here where this one, x is r cosine, -2, or you're going to have to expand some stuff out. And that's what you're going to see on your test. This one, a whole bunch of different techniques. So there's 1, 2, 3, 4 different little techniques that you have to get so that you either get r cosine, r sine, r squared is good to get because that's x squared plus y squared. So study those up. Make sure you know those. The quiz is tomorrow over 9-3. Again, we'll review on Tuesday. And then on Thursday, we're going to take our final. Any questions? All right. If there's no questions, I think that's we can probably end it there. I think that's good enough. Some good notes for you. Make sure you get your assignments done. Make sure you're studying for the final. And we're on the home stretch now. We don't have much left. So hang in there. Stay strong. Stay motivated to do this. When this year's over, you want to be proud of your effort. You don't want to look back and go, I just kind of gave up. And none of you are doing that. So don't do it now. You don't have much time left. So make sure you're doing all your other classes. Stay healthy, stay safe, and we'll see you guys on Tuesday. Talk to you later. Bye-bye.